Hi, I'm Sirisha Rambhatla. I am an assistant professor at University of Waterloo. And in this paper, we are studying how do we fine-tune and pre-train these large language models so that it can be democratized. You and I can do it. So long story short, there are two main ways these days that we are thinking about how do we fine-tune and pre-train these models easily. One track of work is low rank adaptation, which is LoRa, which talks about how weight matrices themselves can be thought to be admitting a low rank structure, and that way we can actually choose a certain set of weights to be updated. And that is a very popular way to do this. More recently, there is another line of work which is looking at the gradient matrices themselves and how gradient matrices can be themselves be low rank. And so Galore, which is was more recently published at ICML 2024, looked at the structure of the gradient and talks about how we can use this low rank structure to efficiently update our gradient every couple of iterations. Now, our work, this is where we come in. What Galore does is that every couple of iterations, it would go in and it would compute singular value decomposition, use those matrices, and project your gradient into the lower dimensional space, make some updates, and project it back again. What we talk about is, in fact, if the gradient matrix is low rank and it is stably evolving, then why not just track the subspace? And there is a long line of work which starts with Laura Balzano's work back in 2010, which talks about, hey, let's actually track the subspace in some other context. We apply a similar idea here and simply track the subspace on this evolving on this Grassmannian manifold and project your gradient lower dimensional subspace, compute the residual, do your calculations there, and move along this geodesic using this the tangent vector, and do your computation again in this beautifully small lower dimensional subspace. Doing this simple thing, which is known as subspace tracking in the literature, we actually see huge benefits. On an average, about 15 to 20%, but in some of the cases for fine-tuning up to 65% speed ups. So this is a work which currently we are only doing rank 1 updates to the subspace, but in the future we could be doing higher rank updates. And what that can enable us to do is do this more efficiently and make it more democratic in the sense that, again, you and I can do it. So that's about it. And if you have more questions, please email. And thank you.